Hi everyone, this is Mrs. GA, and today we're going to start exploring what makes triangles congruent. So we've learned about congruent figures before. In previous sections, the way we showed that figures were congruent was by using rigid motion. So we showed, hey, if you can map one figure onto another using a rigid motion, such as a translation, a rotation, or a reflection, then we can prove that they're congruent. In this section, we're going to start to show other ways that we can prove that two triangles are congruent. So here, let's do a quick recap of some types of statements that we've been using. And to help us with this, I'm going to bring back an example of when we've been using these, the two parallel lines cut by a transversal. And let's say we'll call this angle 1, angle 2, and we'll call this line P and line Q. So the first was a conditional statement. If P, then Q. So we used this before. We would say if the lines are parallel, then the corresponding angles are congruent. So if the lines are parallel, then the corresponding angles are congruent. The converse of a conditional statement is simply swapping the hypothesis and the conclusion. So in this case, we said if the corresponding angles are congruent, then the lines must be parallel. So that's how we used it in the last section. So we're going to talk about two new ones today. A biconditional statement is a statement that can be written as P if and only Q. So in this case, it would be the lines are parallel if and only if, and we can abbreviate that by saying IFF. So this stands for if and only if angle 1 is congruent to angle 2. So the lines are parallel if and only if the corresponding angles are congruent. One thing to note is you can only write a biconditional if the conditional and the converse are both true, because sometimes the converse is not always true. And the last one is the contrapositive. So a contrapositive, you swap the hypothesis and the conclusion, but you also add the word not in front. So if not Q, then not P. So in this continuous example, we would say if angle 1 is not congruent to angle 2, then we conclude that the two lines are not parallel. So it's just two different types of statements that you might be seeing. So let's look down here. So in this figure, we see that we have two triangles, and we see with the given symbols that we have 3 pairs of congruent sides and 3 pairs of congruent angles. So this statement says if triangle ABC and triangle DEF have corresponding pairs of angles and corresponding pairs of sides that are equal, then the two triangles are congruent. So the if is that the sides and the angles are congruent. The then is that the triangles are therefore congruent. So this would be a conditional statement. This is just if P, then Q. So we would call this a conditional. Now this next statement says, if the triangles are congruent, then all of the corresponding angles and sides are congruent. So you could see that the blue part is now first, and the red part is now second. So we've swapped the hypothesis and the conclusion. So we call this a converse statement. So these two statements tie into what's called Cpctc, and it stands for corresponding parts of congruent triangles are congruent. So this is a phrase you're going to be using a lot. So what this phrase means is that you can show that two triangles are congruent by showing that their corresponding parts are congruent. And by parts, we mean angles and sides. So here we see if they are not congruent, then the triangles are not congruent. So if we see that any of the corresponding sides or angles are not congruent, then the triangles are not congruent. Okay, let's see if we can use Cpctc to help us answer this first problem. So it says find the value of the variable that results in congruent triangles. So we would like our two triangles to be congruent. Let's start by matching up the corresponding parts. So one way you can match up corresponding parts is by looking for congruent angles, and that will help you. Another way is to look at the congruent sides. So let's say I decide to name my first triangle triangle CDB. So I need to name the other triangle in a way where the angles match. So here for angle C, I know that it's going to correspond with angle F because they're both 113 degrees. But I can also see that angle C is between a single dash and a double dash. So I look at my other triangle and I say, oh, single dash, double dash, it must correspond with angle F. The next angle I see is angle D, which is right here. I can match the angle measure, so I know it corresponds with angle G. I could also compare the sides. D is between single dash and triple dash, so I find single and triple dash, and I find angle G. So I know that these correspond, which means that B must correspond with E. So remember, according to Cpctc, all of the corresponding sides and angles should be congruent. So we already know that all of the corresponding sides are congruent. Two pairs of the angles are congruent, so we need that last pair to be congruent. So because of Cpctc, we can state that angle B should be congruent to angle E. So we first need to start by finding angle B. So I need to figure out what is this angle. So hopefully we remember that the three angles of a triangle should always add up to 180 degrees. So we can say 180 degrees should equal angle B plus angle C plus angle D. We're trying to find angle B, but we know that angle C is 113 and angle D is 24. So I can combine like terms, so I can finish solving. So angle B plus 137. So that means that angle B is 43 degrees. So now that I know what angle B is, I can go back to this equation that I created using Cpctc, and I can say, okay, 43 should be equal to x plus 17. So we know that B is 43 and we know that E is x plus 17, which allows us to solve for x. So we should subtract 17 from both sides and we get x equals 26. And there you have it. So if x is equal to 26, then that makes these two angles congruent, which results in two congruent triangles. Okay, so let's look at this next one. Here we're trying to decide if triangle STU is congruent to triangle VWX. So we're trying to decide, is triangle STU congruent to triangle VWX? So we are told what the measure of angle S is, but before we even look at the measure of the angles, well, we know that according to Cpctc, all of the corresponding sides should also be congruent. So let's first see if ST is congruent to VW. Is this true? Let me add a question mark up here as well. Okay, I can see that ST is 2, and I can see that VW is 2. So yes, our first corresponding sides are congruent. Let's look at the next pair of corresponding sides. So here I have TU and WX. Let's see if those are congruent. So let's say, is TU congruent to WX? And so if I count over on this one, I can see that this has a length of 7, but WX has a length of 6. So here we say no. And remember, if any of the corresponding parts are not congruent, then according to Cpctc, the triangles are not congruent. So we would say triangle STU is not congruent to triangle VWX, because again, the corresponding sides are not congruent. So we don't even need to look at the angles to determine that they are not congruent. All right, that is all for today's video. Thank you so much for watching.